How to decide whether you need the zoning or not otherwise? Anyone?
If the equipment needs some protection, we need zoning.
Yes, how do you know you need or not? You need or not? So that's my question. Whether you need zoning? Huh?
To conduct risk assessment.
Yes, this is similar to the question in LPS structure. Which class you need to use? You need to do risk assessment. Then you decide your class. Here also, you decide the class or whether you need one or not, depending on the risk. You see, when you do the risk assessment, you define zone. If you don't define the zone, maybe the exposure is there, then the risk cannot be limited. That's why you need to introduce zoning. So I hope you have the zoning inside your risk assessment and the zone actually has certain class, because the search SPD can also go by class. So you not only put the boundary SPD, but the SPD itself has class level, whether you put class 1 SPD, class 2 SPD, class 3 SPD, class 4 SPD. For example, if you put class 4, the risk is still high. So you want to reduce to acceptable limit, you need to put class 1, for example, SPD. Then you're okay. Similarly with shielding. Okay. So there are three or a few content of SPM. This is important. The first one I've already mentioned, earthing and bonding. If you want to have LPS, if you already have LPS, of course you have already earthing. But in addition to earthing, you need to also have bonding to make sure your SPM is working correctly. The second thing, you need to do shielding if you need. And apart from shielding, you can also have, you see, shielding will limit the radiation from outside. But you can also have current flowing in the down conductor, and therefore the magnetic field still can go inside the house because there is a conducting current through the down conductor. So then that magnetic field will be coupled to your wiring, you know, your loops inside the house. Inside the structures, you have your loops, and this loop goes to your equipment. So you need to make sure this is minimized, either shielding the loops or the wiring inside the structure, inside the building. So your wiring inside the house before the equipment need to be shielded, or you can do what we call line routing. And do zoning, and the zoning can be done using also search protection SPDs, and then you can coordinate between the zone. So we have what we call SPD. So you see, previously we have shielding, but if you don't need shielding, because of, for example, it's already EMC free, so you just need the earthing and bonding, and the next one you need zoning by SPD. But if you need the shielding, then you need the shielding as well, zoning by shielding. And alternatively, you can also have what we call isolating interfaces. Okay, so this one is actually the 4 items, the basic content of an SPM. And as you can see in the diagram shown here, you have many incoming lines to your, for example, house. In the house, you have your equipment, in the equipment. And the equipment can be connected to the outside electrical power line, for example, here. So you don't want your equipment, for example, your equipment here, to be exposed to power line. So at the boundary here, you put an SPD, and that SPD will limit any incoming surges before going to your equipment. So the surge will be limited. Okay, so that's the purpose of the SPD there. So therefore, at the boundary there, we have what we call SPD, and then the SPD is to limit the surges that can be propagated through the line, electrical connected wire, which is resistive connection, if you like, to your equipment. But you can also have another SPD here before the equipment. Before your equipment, you have that. So this is coordinated. The one at the boundary and the other one at the close to the equipment. Okay. Now, you must remember this is the boundary. This is the boundary. But the wires, electrical wires or power supply is not the only thing that comes into the house. There are also antennas from the TV. There's also railing from the metalworks. There is also telephone wires, telecommunication wires. There is also water piping that can go in. So all this, you need to put bonding or SPD at the entrance. Because this is what is meant by bonding. So therefore, you have what we call a boundary here, or zone, which have all of the other incoming lines or incoming metal works or wires being bonded together like this. Okay. So when you and this bonding is connected to the ground. So when there is a high voltage on the ground due to lightning, for example, all this at the boundary will be at the same potential. Okay. Now, you can also have a secondary, as I said just now, SPD either at the equipment or another boundary here, for example, another room, which you said, okay, I'm going to put my equipment inside this room. And this room also have many wires or many connecting things goes in. So you have another boundary to define the second zone. And you have put another SPD there. We said SB, switchboard. The first one is MB. Second one is SB, switchboard. So you can put your equipment inside LPZ2 now. So LPZ2 is defined by the SPDs and the boundaries as shown there. You can also have, these are all, you can see now, using SPDs only, no shielding. If you want to do shielding, then you can shield the whole structure by one shield, but here you can see it's not bold line. It's not bold line means there's no shielding. The only shielding that we have is this equipment. It's bold line here. That one is actually to shield from magnetic field. As you know, magnetic field can travel. So if there's no shielding, it can go in. So H not here, H not there also, because there's no shielding. But here it becomes H1 or reduced because there's a shielding at the boundary there. But because we said, okay, we don't worry too much about radiation, only conduction. That's why the zoning here is for conduction. Okay, so remember we have LPZ1, outside is LPZ0. We also have LPZ2 there by using SPD. Okay, any questions so far? We have 3 minutes.
No.
No,
So
okay.
far, okay.
Okay, so there are two things in summary. Our equipment can fail due to radiation or due to conduction. Conduction means surges, radiation means field. Okay, so to reduce the field, you need to use shield, either special or shielded line. Special means you use a thick, structure that actually made from metal that actually shield the magnetic field from coming in. Okay, there's some design for this, the thickness as well as the way you construct the wall. Or you can do combine of them, or you can use what we call it equipment, shielded at the equipment level. But also you can protect your system using zoning by coordinated SPD system. Okay, so you can reduce the radiation by shielding. You can reduce the surge damage due to surge using SPDs. Some equipment already, as I've mentioned, EMC compliant. Therefore, maybe you don't have to worry about radiation, so you just worry about SPD. You can have many zones, not just 1, 2, 3, and so on. So as you can see here, if you increase the zone, that means you put more SPD at the boundaries, or if it's shielding, more shielded at the boundaries. As you can see here. But it is coordinated. It means you must make sure the first one, for example, at the main board, the second one at the switchboard, have SPD which are reducing in coordination. So you reduce it in coordinated manner. Also the shielding, as you can see here, from H0 to H1, as you can see there, by using a shielded wall here. So this is shielded wall. So this is the first one. So this is the second one. So now they have both conducted as well as radiation shielding. So that's why we have LPZ1 and LPZ2. Okay. In this case, we only have one shielding, H0 to H1, so LPZ0 to LPZ1. Similarly, for the surges, also one SPD only at the main board from, okay, for surges, we define as U0, I0 to U1, I1. For radiation, H0 to H1. So these are the field, H0 to H1. But for surge, we goes by